Good afternoon, dear students. I hope we're doing great and keeping safe. Today we're going to be looking at normal distribution, and it's a very critical aspect of statistics. And at the end of this class, we should be able to examine the meaning of normal distribution. We should be able to determine the various regions under a normal distribution curve, and we should be able to find normal distribution probability. So now, if you recall when we started statistics, that's the last semester, we looked at various ways of presenting data. And one of the ways we saw was the use of histogram and other. Now, under the normal distribution, if you decide to use, like let's say you have an histogram like this is your y-axis and this is your x-axis. Now, if I decide to shrink the x-axis, that is reduced to width, while increasing the y-axis, you find out that you get a shape like this, something that looks like this, which when traced out on a curve, it gives us the bell-shaped curve. Now, basically, that is what the normal distribution is all about. You can see when you decide to trace it out, it will give you a shape like this, which is the normal, which is a bell shape, as you can see. That is what the normal distribution shape looks like, and that is why it is sometimes called the bell-shaped curve or the Gaussian curve. Now, having said that, you can see something similar here also. It looks like a bell. That is why it's called the bell shape or the Gaussian curve. This is a very good example of what the normal distribution curve should be like. Now, what then is the normal distribution? The shape of normal distribution curve is illustrated as a bell-shaped curve, and as you can see, that is why it's also mostly referred to as the Gaussian curve, which is named after the popular mathematician Carl Friedrich Gauss. And there are important things you need to understand about the normal distribution curve. One of them is that on a normal distribution curve, the mean, the median, and the mode, the three of them are usually at the same point. They are usually equal. As you can see, this is the mean, this is the mode, the median. The three of them usually fall at the midpoint. Let me just take that out. On a standard normal distribution curve, they should fall at this point where sin is highest. And also, it is also very important to note that in a normal distribution curve, the standard deviation, the mean, are the most important parameters used to determine the location and the shape of the distribution. Please, I'll take that again. The mean and the standard deviation determines the location and the shape of the distribution. Also, the highest point on the normal curve is at the mean. Just like I explained earlier, using this highest point is where you find your mean, your median, and your mode. Another important fact about the normal distribution curve is that the normal distribution curve is symmetric. What that simply means, as you can see the shape here, it is symmetric. And the total area below the normal distribution curve, that is this area, is denoted as what? 1. That is, when you divide this part into 2, the total area under the normal distribution curve, which is the total area here, is what? Is 1. To the right of your mean is 0.5. To the left of the mean is also what? 0.5. When you add 0.5 plus 0.5, that gives you what? That gives you 1. So the total area under the normal distribution curve is what? Is 1. Now, another important fact that we need to understand about the normal distribution curve is that when data in a normal distribution curve are evenly distributed around the mean, we say such normal distribution is a symmetric distribution. However, when they are not evenly distributed, we say it is what? It is skewed. I will take it again. When the data under a normal distribution curve, when it is properly distributed, when it is evenly distributed, we say the normal distribution is what? Is symmetric. But when it is unevenly distributed, that is, majority of the data either falls to the right or to the left of the mean, then we say it is what? It is skewed. Now, when majority of the data, as you can see here, when majority of the data falls to the left, the majority of the data falls around this area, the left of the mean, this is your mean. When majority of the data falls to the left of the mean, we say it is positively skewed. But when majority of data falls to the right of the mean, that is this side, we say it is what? It is negatively skewed. Now, another important thing we need to understand about the normal distribution curve is that this is, let's take for example, this is your mean, as you can see here. Now, please understand is that 68.26% of the values of a normal random variable falls between one standard deviation. This is one standard deviation, either to the left or to the right. It is what? One standard deviation. While 95.4% of the values under a normal random variable falls under two standard deviations. As you can see, this is one standard deviation, this is two standard deviations. The next thing you have to understand is that 99.7% of values of a normal random variable are three standard deviations. Take note, this is one standard deviation, this is two standard deviations, and this is the third standard deviation. Either way, to the right or to the left, you can see. This is one standard deviation, two standard deviation, and three standard deviations from the mean. Now, looking at a standard deviation, if you were to look for where data fall on a standard deviation, it's just a simple formula, which is what? X minus the mean divided by your standard deviation. Now let's take an example. If X is distributed normally with a mean of 100 and a standard deviation of 50, X equals 100, the Z value is what? As you can see here, we are still using the same formula, which is X minus the mean divided by the standard deviation. In this case, our X is what? 200. Our mean, as we have here, is 100. Divided by 50, which is the standard deviation, that will give us a value of what? 2. Now, the next thing we have to do is we draw our normal distribution curve, which is what? As usual, the bell-shaped curve. As you can see, if the mean, as we are told here, remember our mean is what? Is 100. So, and I made mention of the fact at the beginning of this tutorial that the mean always falls at the highest point on a normal distribution curve. So this point where it is highest is where your mean falls. Your mean is 100. Now, two standard deviation, as you can see, this is the first standard deviation, and this is the second standard deviation. So you place 2 under it. Now, the next thing we're going to be looking at is the use of the standardized normal table. As you can see here, since we got the value of 2.0, what you now simply have to do, you look for 2.0 under your standardized normal table, which I have sent to you. And if you remember, I asked us to print it out so that we'll be using it. Now you look for 2.0 under your standard normal table. As you can see here, this is 2.0. Sorry, let me just take care of that properly. So this is 2.0. As you can see, the value to 2.0 is 0.977. So you can say that what a p is less than 2.0 is equal to 9.772. And under your normal distribution curve, as you can see here, when you color out this place, leaving this other part. So for you to get this other part, you can simply just say 1 minus 0.992. When you calculate that out, you'll get what? 0.0228. So why this part is what? 0.977. This part here is what? 0.228. So when you're asked to look for x, when you have to look for x equal 200, when you've been given the mean as 100 and the standard deviation as 50, just simply substitute. This is your formula. You simply substitute 200, which is the value of x, minus 100, which is your mean, divided by 50, which will give you 2. Then you look for 2. Divided by 50, which is your standard deviation, it will give you 2. And you look for 2 under your standard table, it gives you what? 0.977, which is the total area of 2 under your standard deviation, under your standard normal table. When you minus this further, it gives you, for you to get the value of this part, you have to, since we said the total area under this is 1, so you minus 1 minus 0.992. That will give you 0.0228. Now, as you can see, this is the general procedure. This is the general procedure for this. Now, to find the normal probability, suppose that x is normal with mean 8.0 and standard deviation 5.0, and to find p x less than 8.6. You simply have to do is to do what? Normally draw your what? Let me just think that. You draw your normal curve. So you simply draw your normal distribution curve. You draw, and remember this highest point is what is where your mean falls under. And in this case, you're told that the mean is what? 8.0. 8.0. And standard deviation of what? Of 5.0. So you are asked to find the probability that x is less than 8.6. On a normal, to be told that if this is 8, then 8.0 should fall somewhere here. I mean 8.6 rather should fall closer by here, somewhere around here, as you can see here. So you apply this normal formula, x, which is 8.6, minus mean, which is 8.0, divided by 5.0. You get a value of 0.12, as you can see, 0.12. Now, 0.12 that you've gotten, since you've been instructed already that majority of the data, which is your mean, is this, is 8.0, and then 8.6 to fall somewhere here. So you color this whole area out, you color it out, and then you substitute, since you've gotten 8.6, substitute here, which is what, 0.12 as a point two. Now you look for this under your standardized normal table, the 0.12. So this is 0.1, this is 2. So the point where this meets 0.1, 0.2. Let's see, this is 0.1, this is 0.2. The point where they both intersect is what? 0.578. So you simply say F, the probability that Z is 0.12 is equal to what? 0.547. One more example, suppose X, let's say, suppose X is normal with mean of 8.0 and standard deviation 5.0. I say find the probability that X is greater than 8.6. The probability that it is greater than 8.6. So you simply just draw your normal distribution curve here. Roll this out. This is what your mean. Now, your mean, you've been told that the mean is what? 8.0. Now you're looking for the probability that what? I mean, you're looking for the probability that X is greater than 8.6. Greater than 8.6. It means you're dealing with what? The probability that it will be greater than this what? That means data will fall greater than 8.6 ahead of this side. 8.6. This is less than 8.6, as we saw in this case. We saw the probability that it was less than 8.6. So we're dealing with this side. But in this case, we are looking for the probability that it is greater than 8.6, which is this side. So having plotted your normal distribution curve, position your mean, which is 8.0. Now, you see, so 8.6 should fall somewhere around here. This is 8.0, so 8.6 should fall somewhere around here. So the next thing we have to do is to do what? You simply, since you've been told that the majority of, the data under this standard deviation curve is what, the value of the portion under this normal distribution curve is what, is 1. And before now, we've solved when it is less than 8.6, and we got a value of what, 0.12. If you can recall, we got a value of 0.12. So, and on another 0.12, we looked it out on the standard normal table, and then we got a value of what? 0.54. So what we simply have to do in this case, dealing with the probability that X is greater than 8.6, all you simply have to do is to say 1 minus 0.5478. When you minus this, it gives you what? It gives you 0.452. Now, having gotten that value of 0.452, what that simply means is y values at this area up to this point, but 0.5478. This portion is what 0.452, which when you add 0.5, let's say when you decide to add 0.5, when you add this 0.5478 plus 0.4522, you get a value of what? Of 1. So it still gives credence to the fact that the total area under the normal distribution curve is what? Is 1. Now, we could be given a situation to find the x value for a known probability. These are the steps. You find the z value for the unknown probability, then you convert to x using what? The formula. So let's take, for example, as we have here, suppose that x is normal with mean 8.0 and the standard deviation 5.0. Then you have to find the x value so that only 20% of all values are below this x. So you have to do what? Find the x value such that only 20% of all the values are below x. It's still the same pattern. You just simply draw your standard distribution curve, your normal distribution curve, and the highest point here is what makes up your mean. And in this case, you're told your mean is what? 8.0. Having been given a mean of 8.0, the next thing you have to do, you're told to look for x value so that only 20% of all values are below. So you're looking for what? That is below x, is less than x. Less than what? Less than x. If it was greater than x, you're dealing with this side. So now the next thing you have to do is to find the z value for the known probability. So what we do is what? You look for, remember, we were told what? 20%. So 20% is the same thing as 0.2. When you say 20% divided by 20%, sorry, let me go to 20% divided by 100. That will give you what? 0.2. So I haven't gotten that. Now taking your normal distribution table, your standard distribution table, what you simply have to do is look for a value that is close to that 0.2, which is this. Remember how we got it now? You're dealing with 20% divided by 100, that gives you what? 0.2. So you map it out. Since it's less than, it's falls somewhere here. So you look for 0.2 on your table, using this table, the one that I sent to you, 0.2. So you can see the number closest to 0.2 here on the table is what? 0.20005. You can't pick this because this is 0.203. It's a bit further. You simply pick what? 0.2005. This is the value closest. And where does this value fall? It falls under minus 0.8, and then you trace it up 0.4 or 4. So 0.84 is your value. That is how we got this 0.84. So you trace it up minus 0.8 and 4 here, trace down. This is 0.25, which is 0.22. That is the value closer to 0.2. So the values, which is this 0.824. So that is how we got this minus 0.824. So to find the value that z And to find the z value for 20% in the lower tail, the first thing you have to do what? Is to divide the percentage by what? By 100. And then whatever you get, you look for the number closest to it on your normal standardized table, as you can see here. The number closest to 0.2 is what? 0.2005. And it falls under minus 0.8, minus 0.84. So it shows that what? That the area that is consistent with z value of 20% is what is minus 0.84. You can also, as you can see here, investigate. If you want, okay, let's not go into that now. Maybe in our next tutorial, I will show us how to use the other standard number distribution table, the right-tailed standard distribution table, to show you how to use it to derive what this value, as you can see. Or simply, let's just say you're given, okay, let's take that in our next tutorial so that we don't mug it up and then get confused. So it's just a simple, once you're given a value that you to find the z value for the known variable, such that 20% of the area falls under the lower, you simply do what? You divide the percentage by what? By 100, and then you look for the value closest to it. As you can see, the value closest to 0.2, which we got here, is what? It's minus 0.8. And it falls under minus 0. And the value close to that is what? 0.25, and it falls under minus 0.8 and 0.4. So that is how we derive this. So I come your way next time, I would advise us just try your hands on these little questions I've dropped here and see how it works out. Just practice and then let's see, and then show me your answer through any of the medium. You can do that through the normal my CCU platform or your WhatsApp, my WhatsApp account, and so this is able in case you don't have this. I've uploaded it up on the my CCU platform. Please, you can download the PowerPoint presentation and then print out the table in case you didn't get it when I sent it across to you on WhatsApp. So print the table to help you in being able to find everything we've been doing here easier. So till I come your way next time, please, if you have any question whatsoever, please feel free to relate such questions across to me. You can do that using the MyCCU platform. You can chat me up on WhatsApp, you send me a mail, you can even call me directly. You're always welcome. But please feel free please to ask as much questions as you have. Like come your way next time. God bless you and remain safe. Thank you.